26. Yeah, a solid sphere of radius r made of material of bulk modulus k is surrounded by a liquid in which, okay, in a cylindrical container, a massless piston of area A floats on the surface of the liquid. When a mass m is placed on the piston to compress the liquid, the fractional change in the radius of the sphere is okay. So जो पूरा का प्रेशर है वो इंक्रीज हो जाएगा, राइट? दैट्स ऑल वी हैव टू लुक फॉर, राइट? और क्या बल्क मॉडुलस के है, नो बिग डील. सो डेल्टा पी कितना हो जाएगा? Yeah, I mean, of course, we know that, you know, yeah, so stress upon strain, like pressure upon just strain, right? That's like delta V upon V. That's equal to the bulk modulus अपन बोलते हैं generally. Yeah, but the really thing is like dP upon dV, that times V. That's what the bulk modulus is. यानी कि this is equal to like, you get the idea, right? Okay. So अभी हो क्या रहा है exactly इसमें? A solid sphere of radius r, ठीक है, made of bulk modulus बगा हो जो भी. Okay, the fractional change in the radius of sphere is, right? So volume to wo hai, then you can figure out what dP is. dP is so delta p, whatever. It's like mass upon the area, okay, and that's equal to p times delta p upon v in this case. So that's what you need to find. And but the thing is like v is equal to 4/3 of pi r cubed. So right, 3 delta r upon r हो जाएगा. Yeah, that's log लेके differentiate करो, you get the thing, right? That's the thing. So yeah, bulk modulus के अपन लोगों ने की डाला है. So this fractional change, this will just be m upon 3 ak, which is, oh sorry, mg na, because yeah, weight जो है वो mg रहेगा. So mg upon 3 ak, which is b. Next question, 27. 27 करते हैं, चलो. The length of the needle floating on water is this thing. The minimum force in addition to its weight needed to lift the needle above the surface water will be. So surface tension is given. Yes, like the two length. Yeah, 2 times the length. So 5 centimeter times the surface tension is like, okay, this much, 0.0. ठीक है ना, वो अपन कर लेंगे. So like 5 times 10 power negative 2 times 72 times 10 power negative 3, right? That is the force because of the surface tension. अपने को चाहिए minimum force in addition to its weight. So weight तो लगेगा ही, plus अपने को ये force को भी counter करना है, right? So with this thing, yeah, exactly. So this will just be 360 times 10 power negative 5. It's like 36 times 10 power negative 4. So this much, which is like 3.6 times 10 power negative 3. So A is the answer. Next question, 28. 28 क्या है भाई? Okay, a bar of cross section A subjected to two equal and opposite tensile forces as shown. Okay, consider a cross section B. What BB as shown in the figure. Cross section, fine. Okay, the shearing stress at that point is, seriously, shearing stress is cross section mein. Are you serious? I don't understand this. Wait a second. What? But ये तो सही नहीं हुआ. Okay, shearing stress at this point. जो ये क्रॉस सेक्शन रहेगा वो कैसे चेंज हो रहा है, दैट्स द फर्स्ट थिंग. बट क्रॉस सेक्शन चेंज नहीं होता है, अपने को एक ब्लॉक चाहिए रहेगा चेंज होने के लिए. सो आई एम गेसिंग कि ये जो ब्लॉक रहेगा, राइट, दैट्स द वन दैट वी लुक फॉर. सो ये ओके, मतलब ऐसा ब्लॉक रहेगा एट एंगल थीटा विद द वर्टिकल. ओके, सो विद द वर्टिकल एंगल थीटा, और इसका लाइक या ये लेंथ चेंज हो रही है, राइट? दैट्स द थिंग. सो yeah, मतलब ये जो लेंथ थी, दिस लेंथ चेंज टू समथिंग एल्स. सो 1 प्लस स्ट्रेन टाइम्स वॉट एवर लीनियर स्ट्रेन टाइम्स ये जो लेंथ थी, इसको मैं एल बोल देता हूँ. देन द न्यू लेंथ विल बी एल टाइम्स 1 प्लस स्ट्रेन को मैं ई लिख रहा हूँ इस टाइप से, राइट? सो अपना जो चेंज हुआ इज लाइक जस्ट दिस गाय. और तो मैं स्ट्रेन कितना है? ओह गॉड, दिस इज वेरी वियर्ड. You want the shearing stress at this moment. I don't get it. So what force over here, I understand that. Sure. You change why I get that. Like it's trying to get back to what it previously was. Get that. Cross section. Okay, just move on. I don't know इसको कैसे आंसर करूँगा मैं. ये बहुत conceptual भी है, थोड़ा सा अजीब भी है. Next question, 29. A vertical capillary tube inside radius कितना है? R is equal to 0. So small r is equal to 0.25 millimeters, like 1/4 millimeter. Yeah, whatever. 1/4 times 10 power negative 3. Okay, और क्या है? Submerged into water so that the length of its part protruding above the water surface is equal to 25 millimeter. So we call it as, I don't know, whatever. पहले तो इसकी डायग्राम बनाओ. So कुछ तो भी इसका रेडियस जो भी, and it is put inside water, और जो इसके right इसका जो ऊपर का है that's given as 25 millimeter. So h is just 25 times 10 power negative 3, right? Okay. Surface tension is given, so you know what that thing is. 73 times 10 power negative 3. Cool. और क्या है? And the angle of contact is 0 for glass and water. Acceleration to gravity is this thing. Oh god. Then choose the correct statement. R is the radius of the curvature. तो अपने को R कितना है वो अपने को देखना है, right? Okay. And h is the height. Okay, h is what? And h rise in height of water column in the capillary. Fine. No big deal. So suppose यहाँ पे radius which R है, then right, like 2t upon R is the delta P thing. मतलब यहाँ से यहाँ जाने वाला. राइट, तो ये प्रेशर एक्स्ट्रा होगा और ये प्रेशर कम होगा. दैट्स व्हाट वी आर सेइंग. कितना कम? सो ओके, इसमें तुम और आगे जाओगे लाइक दिस प्लस रो जी एच दैट्स इक्वल टू 0 बेसिकली. दैट्स द थिंग. ओके, सो अपने को एच दिया हुआ है, राइट? कूल. ऑफ कोर्स एच इज द हाइट ऑफ वाटर कॉलम इन द कैपिलरी. हाँ, वो तो उतना ही है ना, ये अपना जो 25 मिलीमीटर था. दैट्स द थिंग. श्योर. पार्ट प्रोट्रूडिंग जो भी है. सो अपने को आर ढूंढना है. आर इज जस्ट इक्वल टू 2t अपॉन रोज. इसको नेगेटिव वगैरह दे लो बट वॉट एवर यू गेट द थिंग. सो पी नॉट, सच में इसको बताना चाहता हूँ, नेगेटिव आएगा ना यहाँ पे. या सो 2t अपॉन रो जी एच विच इज 2 टाइम्स सरफेस टेंशन कितना है? 73 टाइम्स 10 पावर नेगेटिव 3. ओके, नीचे आ जाएगा रो कितना है? दिया नहीं अपने को, but we know it's just 1 gram per centimeter, like 10 power 3. Okay, then g कितना है? g तो 9.8 रहेगा. Cool. And then h, so ये चीज 25 times 10 power negative 3. और ये जो चीज थी, ये रेडियस क्या वो एक्चुअल में यूजफुल भी रहा इनफैक्ट. वेट, that's weird. Angle of contact 0 है. But something's not correct about this. We know कि angle of contact 0 है, right? Yeah. Oh, okay. So right. Okay. H is dependent, in fact. Oh God. ये सही नहीं हुआ. Anyway, we know that capital R is just equal to, right? That's like, of course, ये ऐसा हो जाएगा ना. अगर ये angle of contact 0 है, then it's gonna be like this. तो यहाँ पे ये exactly match होगा. So capital R must be equal to small r. That's the only thing. So right, और small r कितना है? या ये चीज. So 0.25 millimeter. So A तो correct है at least. अपने को करना क्या है? Correct statement. So I guess A will be correct and all of the other ones will be incorrect or something. A should be correct. No big deal. अगर angle of contact 0 दिया है then it's correct. और क्या अपने को height भी निकालनी है. ठीक है. So height can be found out like this thing. 2t upon rho g times r. So यहाँ पे बस h के जगह पे r पुट कर दो, which is 0.25 millimeters. Okay, यहाँ पे 1/4 डाल दो and let's calculate this. So approximately 10 ही लो ना, क्या जा रहा है? क्या हो जाएगा ये? ऊपर जाके 8 times 73 times ये तो गया just 10 power 4, so 10 power negative 4 like that, right? These many meters. So basically yeah, okay, कितना जाएगा ये? क्या 584, so 58.4 millimeter, right? Which is not here. 59.67, which okay, maybe it makes sense. So like maybe B is correct, but ये multiple choice तो है नहीं. So how does that make sense? नहीं यार, ये तो सही नहीं है, because how can that be? Most likely A is the correct one and this is wrong, but I think A और B दोनों correct है. But whatever. Next 30 क्या है? A ball of relative density कितना 0.8 falls into water from height of something. The depth to which the ball will sink is. Neglect viscous force. Okay, wait, what? Viscous force को neglect करना है मुझे? That's weird. So okay. Relative density 0.8 falls into water from height of 2 meter. ओके एंड द डेप्थ टू विच द बॉल विल सिंक, तो इसमें कंटिन्यूसली पॉइंट फोर्स लग रहा है लाइक या सो वेट ओके इसकी डेंसिटी कम है वाटर से, लाइक 0.8, मतलब ये 0.2 का फोर्स पे ऊपर लगने वाला है राइट। तो पहले 1 से एक्सेलरेशन हुआ, फिर 2 से हुआ, यू नो द v स्क्वायर माइनस u स्क्वायर इक्वल टू 2s, एक्सेलरेशन कांस्टेंट है, इनिशियल फाइनली 0 था, सो दोनों में जो v स्क्वायर है दैट्स लाइक सेम थिंग, सो 2a, सो इनिशियल जो a था राइट, हाँ ठीक है, मतलब as कांस्टेंट है, इसकी जो इनिशियल हाइट थी 2 टाइम्स इसका जो पहले एक्सेलरेशन था जिससे 1g का एक्सेलरेशन रहने वाला है, दैट्स इक्वल टू जो भी अब इसकी डेप्थ है टाइम्स इसका जो डिसलेशन था विच वाज आई गेस 0.2 बिकॉज या रिलेटिव ग्रेविटी 0.8 है, सो yep that is same, so like h is just equal to 10 right or not, why is that not there, god, the ball will sink, neglect viscous forces, sure, ball will sink, I mean yeah just वो वहां तक जाएगा and then it's gonna go up, so right like if your ball इस पे acceleration लगने वाला है, it's like this g downward but then so इसने displace किया right because of that, so actually it's 0.2 g upwards right, so h must be 10 but that's not here for some reason, god what's even going on over here, right 2 meters यहाँ से नीचे गिरा, ओके that will always sink, जब ये वाटर में है इसका एक्सेलरेशन क्या होने वाला है जी बताओ, सो g इज डाउनवर्ड, इसका एक्सेलरेशन हो गई एंड देन इसे बॉयंट फोर्स लग रहा है, सो बॉयंट फोर्स इसकी जो भी वॉल्यूम है टाइम्स डेंसिटी ऑफ वाटर राइट, दैट टाइम्स g, तो वो ऊपर है एंड देन दिस थिंग अपॉन द एक्चुअल मास, सो वॉल्यूम इज सॉलिड, सो रो w अपॉन रो s, okay and rho s is 0 right, ये जो रेशियो is like 1 upon 0.8, so this is 1 upon 0.8 times g, okay इसलिए गलत हुआ, so like 1 upon 0.8 minus 1 that's the upward thing, मुझे यहाँ पे ये पुट करना चाहिए था, and 0.8 क्या हो जाएगा, 10 upon it's like 5 upon 4, so this minus 1 is like 1/4 over here, ये गलत हुआ, आप समझा क्या हुआ है, so h is just equal to 8, which is a option, next question, next 31 क्या है, a small wooden ball of density rho is immersed in water of density rho up to okay sigma up to depth h and then released, okay once in the water and then released, the height h, once again the same stuff, okay right, so once again क्या था density, so the upward force that's just density of the water upon density of ball minus 1 times g right, ये इसका upward acceleration रहने वाला है, yeah so this times जो इसकी initial height depth थी right, okay so depth h right, that will just be equal to जो इसकी final height है water surface के ऊपर times इसका जो deceleration रहने वाला है which is gravity 1, yeah h is this thing right, easy as that, density of water कितनी है, density of ball कितनी है, ये चीज and this is sigma minus 1 times h which is 31st का b, next question, क्या हो रहा है, 32 is a tube is attached as shown in the closed vessel containing water, okay the velocity of the water coming out of the small hole is what, seriously what, a tube is attached as shown in a closed vessel containing water, ये क्या चीज है ये exactly हो क्या रहा है यहाँ पे, coming out of these small hole, so ऐसा है कि ओके यहाँ पे एटमॉस्फेरिक प्रेशर और आई गेस यहाँ पे प्रेशर कम है एटमॉस्फेरिक प्रेशर से, सो इसलिए वाटर ऊपर आ चुका है राइट, या आई गेस एंड इसलिए यहाँ पे एयर बबल्स भी आ रहे हैं, ओके एंड देन जो वाटर है वो ऐसे निकल रहा है, दिस थिंग इज द एटमॉस्फेरिक प्रेशर, सो एक्चुअली में ये जितना लोअर है अपने को वो देखना है एंड राइट दिस थिंग क्यूब से इसका डिस्टेंस कितना है 20 सेंटीमीटर या ओके सो बेसिकली वही वन सेकेंड स्क्वायर रूट ऑफ 2gh बट यहाँ पे h अपने को 20 सेंटीमीटर डालना है नॉट दिस कंप्लीट हाइट सो स्क्वायर रूट ऑफ 2 टाइम्स 10 टाइम्स h कितना है 20 सेंटीमीटर व्हाट नो ओके दैट्स लाइक 0.2 meters. Ooh, that's bad. It's like 1/5. Fine. So square root of 4 basically. That's 2. So 2 meter per second, which is B. Next question. 33. 33 क्या है? A cylindrical vessel filled with water up to height of H stands on a horizontal plane. The side wall of the vessel has plugged circular hole touching the okay, draw करो cylindrical vessel filled up to water of height H. Okay. Stands on horizontal plane. The side of the vessel, side wall of the vessel, has a plugged circular hole touching the bottom. So as supposed to be. The coefficient of friction between the bottom of the vessel and plane. What? Oh, okay. समझा. So इसके ऊपर ये चलने वाला है ना? Okay, I get it. So ये जो plane है, right? Is mu and total mass of the water plus vessel is capital M. What should be the minimum diameter of the hole so that vessel begins to move on the floor if plug is removed? हाँ ठीक है, I can do this thing, no big deal. So once again the v square चाहिए अपने को, right? A v square and then क्या था density भी थी. A v is the volume flow rate and density is like mass flow rate. Density is the force basically, right? So rho A and then you just got 2gh, right? This is the force on this guy. So ये चीज upon the mass of the complete system. That's the acceleration. मतलब ठीक है ना जो ये वाला जो पूरा बचा हुआ रहेगा this will be m, right? Yeah, of course. Okay. So upon and of course relative velocity रहने वाली है इसमें but well whatever we don't care about that because initial zero है नहीं है. Okay. So upon capital M that is the this is the acceleration, right? या फिर काम डायरेक्टली फोर्स की बात करते हैं. So this force this must be bigger than the gravity. This must be bigger than the friction force, like mu times of m times g, basically. Yeah. Exactly. Vessel begins to move on the floor if the plug is removed. Density of water is this thing, right? Let's do it. So ये g गया, ये ऐसे क्या आ जाएगा? And what's the what? Minimum diameter of the hole. सब देखो A जो है वो ढूंढना है पहले तो. A is bigger than mu m upon 2 rho h. Isn't that right? I guess so. So pi r squared. No, wait, pi d square upon 4, right? So d upon 4. Yeah, that's bigger than that. So that just means pi d square is bigger than, okay, d square is bigger than 2 mu m upon pi rho h. तो उसका square root ले लो, right? Square root of 2 mu m upon pi rho h, which is option A. Next question. 34. 34 करते हैं चलो फटाफट. Okay, a solid metallic sphere of radius r is allowed to fall freely through air if the friction resistance due to air is proportional to the cross-section area and to the square of the velocity, the terminal velocity of the space proportional to which of the following, right? So तब क्या होगा? All you got is like it's proportional to what? Square of the velocity and also cross area is like proportional to r squared, right? Okay, so some constant times ये चीज. Yeah, that's equal to, so ये discuss जो force रहेगा resistance force whatever that is equal to जो gravity रहेगी, that's yeah. And density constant रख रहे कि क्या? Oh god, लोग मुझे बताओ तो एटलीस्ट डेंसिटी अपन कांस्टेंट रख रहे हैं कि क्या कांस्टेंट रख रहे हैं. खैर तो नहीं बताएंगे ऑफ कोर्स बिकॉज जे मेंस है. ठीक है, अज्यूम करो डेंसिटी कांस्टेंट रख रहा है. सो 4/3 pi r cube times rho and that times that times g same. So v square is proportional to r basically अगर अपन डेंसिटी को कांस्टेंट रखते हैं तो which means v is proportional to r power negative, sorry, r power 1/2, which means option D. I know घटिया क्वेश्चन है बट क्या कर सकते हैं. 35th क्या है? Two drops of same radius are falling through air at a steady with the steady speed of something. If the two drops coalesce, what would be the terminal velocity? Okay, let's do this thing. इन दोनों की डेंसिटी सेम होगी ना? या सो जो एक रेडियस r का ड्रॉप गिर रहा है उसके लिए क्या होगा? So 6 pi r कुछ viscosity, velocity, whatever. This is equal to 4/3 pi r cubed times density times gravity, whatever. तो ये तो constant है सारे terms. So really just velocity is proportional to r squared basically. And yeah, इनका जो r cube है that's gonna remain constant. So same radius. तो अब इनका r क्या हो चुका है? इनका r हो चुका है 2 times, right? इनका r cube is 2 times small r cube. मतलब कि cube root of 2r is now the new radius, right? So अब new velocity कितनी होगी? It's gonna be equal to 2 की power 2 third times velocity or previously, right? Yeah, so वो कहाँ पर है? V64? What? No, that's not right. R cube is constant. It's cube root. What is going on? Yeah, what's the thing? Try to force this guy. So r squared and just like 2/3. इसमें है ही नहीं आंसर. ये क्या चीज? Oh, अच्छा d का मतलब like diameter. Wait, no, something's wrong about this. D what? Whatever. I think 4 power 1/3 होगा, but जो भी I guess B is the only answer that can probably make sense because बाकी सारे में 1/3 नहीं है. So next question, 36th. Drops हैं by the way. Yeah. 36th cubical block of side A and density row slides on a fixed inclined plane with constant velocity v. There is a thin film of viscous fluid of thickness T between the plane and the block. Then the question of viscosity of the thin film will be fixed inclined plane with constant velocity v. Okay, thin film of viscous fluid of thickness T between the plane and the block. Oh god, seriously. Then the question of viscosity of the thin film will be constant velocity. That's the only thing, right? So yeah, like mg cosine theta, sine theta. That's this force. Friction तो है नहीं इसमें कुछ because water के ऊपर चल रहा है. This is equal to the viscous force, which is जो भी इसकी velocity थी times जो भी इसका area था, right? Which is like a square cubical है ना, right? और density rho है, so m की जगह मैं just a cube times rho डाल दूँगा, so rho a cubed. So yeah, okay, and that thing upon the distance between is right thickness t. That's the thing. This is the velocity gradient. Cool. So ये गया. तो अपने को क्या चाहिए वैसे? क्वेश्चन oh yeah, this time's question discuss. मैं भूल भी सकता हूँ. तो कौन सा है इसमें से? और थीटा क्या है? Oh, is 37. Fine. So sin क्या हो जाएगा? 3/5. Right, so like 3t rho ag upon 5v whatever. So a जो है that's the thing. So next question. Right, 3t rho ag upon 5. Yeah, next question. 37. 7 क्या है? Okay. So the following graph best represents the motion of a raindrop. So पहले तो फॉर्म होगा, उस वेलोसिटी 0 हो जाती है, फिर बाद में नीचे गिरस्ट होता है, वो एक्सीलरेट हो रहा है, वो एक कांस्टेंट वेलोसिटी चला जाता है. या सो समथिंग लाइक दिस आई गेस. ये तो बहुत गंदा है और ये सही नहीं है और ये भी सही नहीं है. सो सी इज द आंसर. नेक्स्ट 38. So following is the incorrect graph for the sphere falling in viscous liquid. Okay. Viscous liquid, right? Okay, so कभी ना कभी तो right. So A is the correct graph. So velocity तुम्हारी कैसी है? Okay, और ये क्या acceleration? और this is the displacement, हाँ? Right. So after some point वो linear हो जाता है, right? And then initially 0 है and it's going up. Initially it's pretty much going up like a parabola, right? So initially velocity is going up like a line और ये parabola से ऊपर जा रहा है, but whatever, you know the thing, of course. So D और A तो correct लग रहा है, and what about B and C? So acceleration is a time. So initially acceleration कैसा है? It's positive. What? Yeah, actually it is. और फिर ये डिक्रीज हो रहा है. मुझे सब कुछ निकालना ही पड़ेगा क्या? There is really no other way. Fine. So do the thing. So क्या है इसका डिफरेंशियल इक्वेशन कैसा होगा? Like dv upon dt is equal to, so कोई तो भी कांस्टेंट है इसमें g माइनस जो इसकी वेलोसिटी से प्रोपोर्शनल कुछ तो भी है. So yeah, like this thing. Of course, that's how it's supposed to be. So yeah, मतलब कि क्या natural log of g minus kv upon negative k is equal to t plus some kind of constant, whatever. Initially to zero है ना, so just go from zero to v finally. Yeah, just go from zero to v. So that's like saying natural log of g minus kv upon g, that is equal to negative kt. मतलब कि g minus kv is just equal to e power negative g times e power negative kt. Isn't that right? Maybe it is, maybe it's not, who knows. Hopefully correct though. What does that mean? It just means like, okay, kv is just equal to, right? So acceleration is basically like this thing, right? Yeah, okay. Acceleration is just g e power negative kt, and also acceleration is just linearly related to time, to velocity, right? So c is in fact incorrect. Yeah, because वो linearly related चाहिए अपने को. That's wrong. Okay, next. ये पूरा करने की जरूरत नहीं थी. 38, 39 करते हैं. Displacement of a ball falling from rest in viscous medium is plotted against time. Seriously. अब तो तुमने मुझे डी दे ही दिया तो मैं वही इसमें छाप दूंगा ना. What's the big deal? Right? मतलब ठीक है, वापस इक्वल कर लेते ना. G minus k times v is equal to g e power negative kt था ना. Yeah, that was the velocity thing. So यहाँ से जाता है v is just equal to g times 1 minus e power negative kt. So gx is just equal to इसका integrations like g times of t minus. Isn't that right? Of course, velocities like that just gotta integrate to get the thing. So negative, and then okay, इसमें positive हो जाएगा e power negative kt upon k, and it's going from t equal to 0 to sometime t. So t equal to 0 पे x 0 हो जाता है. That's why like wow, इस x रहेगा, and it's actually supposed to be this minus 1 आएगा यहाँ पे. Yeah, that's the thing. So it behaves like that. मतलब कि जब t approaches infinity, is like kx is equal to gt or something like that. Okay, gt minus कुछ तो भी, right? And that's why like a line, or initially 0 है, whatever. This is the way the graph should look like. So हाँ, I guess D is the way. So oh, ये 39 था. हाँ, कर ही चुके ना अपन. 38 का अपने C किया था. Fine. 40 करते हैं. 40 is a 1 millimeter thick layer of glycerine is placed between flat plate of area something. Okay, 10 times 10 power negative 100, 10 power 2 times 10 power कितना negative 4, 10 power negative 2 basically. 1 millimeter thick layer. So the thickness D बोल रहा हूँ उसको. That's equal to 10 power negative 3. Of course. And a big fixed plate, if the question of viscosity is this guy. Okay, 1. Then how much force is required to move the plate with velocity 7 centimeters, like 10 power negative 2. These many meters per second, right? Okay, अब देखा चाहिए force required to move the plate. Of course. So yeah, I mean just A times V upon D times quotient viscosity, right? So 1 है ये कितना हो जाएगा? 10 power negative 2 times V is just 7 times 10 power negative 2 upon D is 10 power negative 3. तो यहाँ से ये गया 10 power negative 1 हो जाएगा, यहाँ पे आ जाएगा 10 power negative 1. So 0.7 newtons, which is option B. Next question. 41st. 41st करते हैं चलो. A container whose bottom has round holes with diameter 0.1 millimeter is filled with water. The maximum height in centimeter up to which the water can be filled without leakage will be. Round hole with diameter something is filled with water. What? The maximum height up to which water can be filled without leakage. Wait, that doesn't make any sense. समझा नहीं मैं इसमें exactly क्या कर रहे हैं. Container है, bottom has a round hole with diameter 0.1. Okay, filled with water. Fine. The maximum height up to which water can be filled without. Oh, surface tension is given. Oh, okay, that makes sense. Right, तो इसे bulb form करेगा. I get that. Right. तो pressure कितना हो जाएगा? Just rho gh, right? Okay, and this pressure is just equal to, तो क्योंकि A की surface is like okay 2t upon r, right? So you know maximum जो delta p रहेगा that will be produced when r is just equal to the smallest value जो कि है the radius of the hole, right? Yeah, और diameter 0.1. ठीक है ना, वो अपन कर लेंगे. That's the thing. So अपने को चाहिए height is gonna be 2t upon rho gr basically, which is 4t upon rho gt I would say. So चलो कैलकुलेट करते हैं. 4 times surface tension कितना है? 75 times 10 power negative 3 upon density 10 power 3 होती है times gravity times t की value, right? So it's 0.1 millimeters 10 power negative 4 basically, right? This is going to be 300 times 10 power negative 3 times 10 power negative 1 basically upon 10 power 4 of 10 power negative 4 हो गया. So 0.3 meters मतलब कि 30 centimeters. So C is the answer. Next question. 42. Is a liquid is filled in a spherical container of radius r till a height h. Okay, at this positions the liquid surface at the edge is also horizontal. What? Radius r till a height h. At this position the liquid surface at the edge is also horizontal. So at the edge कौन सी edge यार? The contact angle is okay, तो जो वो right surface tension है वो complete right. I get that. Right. So you know tension is just acting like that, nothing else. ये ऊपर चढ़ नहीं रहा है इसके. Yeah, that's the contact angle. This thing is the contact angle, right? So इसके बीच में है and it's at height h. So ये जो रहेगा, let's just do this thing. We just want ये वाला angle, right? Call this in theta. तो ये angle that is theta होगा, ये होगा theta in that case. And this is radius r. This thing is just r minus h. So cosine theta is equal to r minus h, like cosine inverse of r minus h upon r, right? So B is the answer. This is the contact angle, I guess. Isn't that correct? Yeah, I think that is in fact. Next question. 43. A long capillary tube of radius r is initially just vertically immersed inside a liquid of angle of contact 0 degree. If the tube is slowly raised, then the relation between the radius of curvature of the meniscus inside the capillary tube. Long tube initially just vertically immersed inside inside a liquid of angle of contact 0 degree with the capillary tube, that is. If the tube is slowly raised, okay, then relation between radius of curvature of the meniscus inside the capillary tube and the displacement of the tube can be represented as. So slowly, right? That's the main thing. Acceleration 0 है. So it's just like okay, like this. और फिर यहाँ पे भी है, we don't care about that. This is where you got the atmospheric pressure, I guess. Yeah, मतलब बहुत दूर कहीं तो भी तो atmospheric pressure होगा, and then you can just do like this. Makes sense. So ये atmospheric pressure है, यहाँ पे atmospheric pressure है, ये जो है it's less by rho gh. So yeah, like ये जो radius रहने वाला है, and we just want the radius of curvature. So of course like 2t upon capital R, that thing is going to be equal to rho gh, right? Where h is this height. Cool. Tube is slowly raised and the relation between radius of curvature of meniscus inside the capillary tube and displacement h. Of course, like this. Of course. अच्छा, अगर तुमको ये जीरो करना है, then r must be what? Infinity plus like flat surface of ऊपर जा रहे हो, सबसे बढ़ा रहे हो. Makes sense. So I guess this is the thing. So at least for big enough values of h, it's gonna work like that. तो अपने को चाहिए रेडियस ऑफ कर्वेचर, दैट्स गोना बी इक्वल टू 2t अपॉन रो जी एच, सो काइंड ऑफ लाइक अ हाइपरबोला. मतलब आई गेस सी इज द वे, right? So for big enough values of h, it actually does behave like that. Yeah, like a hyperbola completely. For small values, it's kind of complete. ये क्या हो रहा है? What is this? And what is this? I guess B is correct. But ये line का क्या मतलब है आखिर? I don't know. I'm gonna go with B. Oh no, यहाँ पे एक horizontal asymptote कर दिया लगता है इन लोगों ने. No, that's not supposed to be there. और ये इसमें ऐसा curvature तो नहीं चाहिए. It's just a hyperbola. वो कहीं क्यों नहीं दिख रहा मुझे ग्राफ? और इतना सेम क्यों लग रहा है? Not nice. I don't know यार, BC दोनों डाल देता हूँ वैसे. Okay, next. अब वो तुमने ग्राफ गंदे बनाए, तुम्हारी गलती. 44. A cylindrical container of radius r and height h is completely filled with liquid. Two horizontal L-shaped pipes of small cross-section A are connected to the liquid as shown. क्या? Two horizontal L-shaped pipes. दो pipes. Okay. Now the two pipes are open and fluid starts coming out of the pipes horizontally in opposite directions. Okay, then the torque due to ejected liquid on the system is interesting. Okay, so the torque चाहिए, right? Due to the ejected liquid on the system, of course. So once again, energy equation लगा, you get the thing, right? Of course, that should make sense. Like जो pressure रहेगा, that's the thing. इसमें speed है, so like okay, velocity भी है इसमें, but just assume वो zero थी initially, so अपन initial के बारे में बात कर रहे हैं. Then in that case, just ये h upon 2 जो नीचे जा रहा है, एक काम करो यार, h upon 2 कितना गंदा दिया इन लोगों ने, इसको h देना चाहिए था. And this is like okay, cool. I just hate this. ठीक है, it's like rho g h. This is the velocity with which these leave, right? So you know the thing, v square karo that times area, that times the density, so rho square a g h or something. Isn't that right? Wait, ऐसा ही रहता है ना? Oh shit, it's just square root of gh, not rho gh. Okay, this is the thing, rho a g h, that is the force basically, right? तो इस पे जो propulsion force लगेगा, and yeah, this guy is like r, but ये तो already r है, so about this axis तुम्हारे पास में 2r रहेगा, right? So this times 2r, और वो वहाँ पे, so दोनों in fact same ही जगह पे जा रहे हैं, right? So ऐसे actually अपने को 4 times करना पड़ेगा, 4 and then r like that. This is the torque. Yeah, I should do it. So कहाँ पर है आंसर? A. Next question. Right. Next. Hopefully correct हो ये. Then 45th. In the figure shown, in the figure shown, water is filled in a symmetrical container. 4 pistons of equal area A are used at the 4 openings to keep the water in equilibrium. Now, an additional force F is applied at each piston. Equal area बोल रहे हैं, हाँ? Water is filled in a symmetrical container. Okay. Now, additional force F is applied at each piston. The increase in the pressure at the center of the container due to the force is, of course, just F upon A. What's the big deal? So A is the answer. क्या बोलते हैं उसको? Pascal's law. Yeah. Okay. Pressure omnipotent है. Next. Omnidirectional रहता है शायद से. Whatever. A non-uniform cylinder of mass m, length L, and radius r is having its center of mass at a distance L upon 4 from the center. Okay. Cylinder of mass m, length L, and radius r. तो ये सिलेंडर है और ये इसके दो एंड्स हैं. ओके. Is having its center of mass at a distance L upon from the center. Oh god, center of mass पूरा है. ओ क्या सच में? ये सही नहीं लग रहा मुझे. Lying on the axis of the cylinder. The center is kept in a liquid of uniform density rho. The moment of inertia of the rod about the center of mass is I. The angular acceleration of, so closed cylinder ने I guess it's a closed cylinder, otherwise ये बहुत गंदा रहेगा. The uniform acceleration of the point A relative to the point B just after the rod is the angular acceleration. Okay, just after rod is released from position shown in the figure is, तो अपने को basically torque ढूंढना है और डिवाइड करना है inertia से. Oh god. Torque about center of mass. uh, I'm assuming कि जो सिलेंडर है वो क्लोज्ड है इनफैक्ट, राइट. ओके, तो यहाँ से प्रेशर पड़ रहा है, यहाँ से प्रेशर पड़ रहा है, वी डोंट केयर अबाउट दैट. ये जो प्रेशर डिफरेंस है दैट्स द थिंग दैट वी एक्चुअली केयर अबाउट, राइट. ओके, तो हमारे पास में ये जो ये जो अपना सिलेंडर है इट्स लाइक दिस. यहाँ पे जो सेंटर ऑफ मास है ये एक्चुअली में सेंटर था इसका, इट्स एट डिस्टेंस L/4, राइट. कोर्स और R क्या है बाय द वे? R इज दिस रेडियस आई थिंक. ओके, कूल. सो ये वाला जो इतनी जो अपन डिस्क ले लेंगे, डिस्क नहीं क्या जो भी है ये, इसके ऊपर जो फोर्स लगेगा बिकॉज ऑफ द प्रेशर दैट्स गोना बी अपवर्ड. सो ये जो एरिया है, राइट, दिस इज द वन वी लुक फॉर. इट्स गोना बी dx. तो ये दिस इज x ले लो, व्हाटएवर. dx इज दिस विड्थ और गॉड, और ये लेंथ कितनी होगी? 2r, right? So 2r dx, and that times pressure, I should say pressure difference or whatever. Yeah, I mean of course it's something वो area लेना है and it will work out. It will work out, I guess. Wait, pressure change हो रहा है accordingly, like this is upon density. Not nice, not nice. ये तो सही नहीं हो रहा है. काइंड ऑफ थिंक ऑफ इट लाइक कि इसको तुम बहुत सारे सेक्शंस में तोड़ दोगे. सो लाइक ऐसे सेक्शन में तोड़ दिया एंड देन इसके ऊपर अपने बॉयंट फोर्स देखा कितना है. या मे बी दैट्स वन वे टू थिंक अबाउट इट इंस्टेड ऑफ डूइंग दिस, राइट. या तो फिर ओके, लेट्स ट्राई इट आउट. But it's okay, it's a non-uniform. अपने को सिर्फ वॉल्यूम से रिलेशन है ना. या वी डोंट केयर अबाउट द अदर स्टफ. सो सेंटर ऑफ मास कहीं तो भी यहाँ पर है, इट्स अ डिस्टेंस L/4, मतलब कि इसका ये क्या डिस्टेंस होगा फिर? L/2 plus L/4, 3L/4, एंड दिस डिस्टेंस गोना बी L/4, राइट. सपोज ये डिस्टेंस x अवे है फ्रॉम राइट फ्रॉम दिस गाय, और dx, राइट, लाइक ओके basically dx upon the total length, that is, yeah, okay, and that times the total volume. Total volume कितनी है? Length times the area. Okay, dx times the area, right? Maybe that's the better thing to do. So dx times area is the volume of this guy, right? And the density of the liquid, which is rho, just taking that to be rho, then times g, that's the buoyant force on it, and then that times x, it's gonna give us the torque, राइट. आई होप सो. और क्या इससे ग्रेविटी जो लगेगी वो तो कंप्लीटली अपन, हाँ, वो अपन इग्नोर कर सकते हैं, नो बिग डील. एंड ऑल ऑफ दिस अपॉन, सॉरी, अपने इसको पहले तो इंटीग्रेट करना है. इंटीग्रेशन फ्रॉम x इक्वल टू -3L/4 to L/4 and all of that upon inertia. That's what you want, right? Right, that will be torque. That's going to give us the angular acceleration, sure. So rho a g, or a क्या है, which is pi r squared. So rho pi r squared times g upon I, and then this guy is like x squared upon half L/4 का square. So L/4 का square अपन बाहर निकाल लेते हैं, and then yeah, okay, 1 minus, ठीक है ना, उल्टा ले लो कैसा भी ले लो फर्क नहीं पड़ता. इसका भी 9 - 1, that's what counts. So ये हो जाएगा 8, isn't that right? So ये हो जाएगा 16 in that case, और ये गया 2, so इसका भी 4. तो रो पाई आर स्क्वायर जी, यहाँ पे नीचे 4 आने वाला है, एंड देन यहाँ से आ जाएगा L स्क्वायर, राइट, जो किस आंसर में है? इस आंसर में है रो पाई है, ठीक है ना, वो अपने आप हो ही जाएगा, नो बिग डील अबाउट दैट. सो बी इज द आंसर. नेक्स्ट क्वेश्चन 47th. 3-4 और 47th is the figure shows a soap film in which a closed elastic thread is lying. The film inside the thread is pricked. Now the sliding wire is moved out so that the surface area increases. Okay, sliding wire है, elastic thread है. Soap film में a closed elastic thread is lying inside the thread is pricked. This is very weird. Inside the thread. What? It's pricked. Oh, okay. Right. और ये elastic thread है. Well, that doesn't look good. It's like, okay, it's pulling it at every direction, right? So इसलिए ये okay. Now the sliding wire is moved so that the surface area increases. The radius of the circle formed by the elastic thread will be the same. In fact, what's the big deal? You know, surface tension थोड़ी ना change होता है. Yeah. So it will remain same. So 47 का C. Next 48. A capillary of the shape as shown in the shown is dipped in liquid. Contact angle between liquid and capillary is 0 degree. Oh, effective to liquid inside the meniscus to be neglected. What? It's the radius of meniscus and rho is the density of liquid. Then height h in equilibrium. Wait, what? Liquid and capillary is 0 degree. Inside the meniscus, that's to be neglected. मतलब क्या करना है मुझे exactly neglect करके? और effect यानी तुम क्या बोलना चाहते हो? Density of a liquid and H. So equilibrium में H क्या होगा, right? That's what you are asking. I mean, और H exactly है क्या? तुमने कुछ मुझे बताया नहीं, तो मैं कैसे solve करूँगा? But I'm guessing कि question ऐसा है कि like rho g H is equal to I know. और R क्या है by the way? Radius of the meniscus. Oh god. You mean radius of curvature or you actually mean the radius? Like the radius at that point. No understanding क्या होना चाहिए इसमें. I guess तुम ये जो शायद से ऐसा है, नहीं तो right, so I'm guessing कि ऐसा हो रहा है, like this is the radius they're talking about, और ये जो पूरी चीज रहेगी that's only capital R. So this is what they're talking about, the radius of meniscus. शायद से हो सकता है कि capital R is the radius of meniscus. I don't know. So if this is the case, right? Okay, it's getting this kind of, what is this? This angle is going to be 0. Okay, that's the contact angle over here. और ये जो angle अपने को दिया नहीं है, God, ये angle अपने को दिया नहीं. How am I supposed to solve this? Right? Doesn't make any sense. The center of curvature कहाँ पे होगा? We don't know unless we actually know the. Yeah, okay. I guess radius of curvature ही बोल रहे हैं वो. In that case, it's just equal to 2t upon r. So h would just be 2t upon r rho g or something like that. You know what? Let's skip this. I don't know. I just don't know कि यहाँ पे क्या हो रहा है. Honestly. Oh wait, I think r is really like this thing and not this thing. अच्छा अगर ऐसा है oh and it's greater than equal to तो नहीं है, less than क्या है exactly ऐसा पूछ रहे हैं ना. Yeah. So as you can see, capital R is bigger than small r, right? So 2t upon rho g capital R. So because capital R is bigger than small r, this thing is going to be less than 2t upon rho g small r. So C is the answer, I guess. I don't know. Next question. 49th. पहले तुमने क्वेश्चन बुरा लिखा है और तुम मुझसे एक्सपेक्ट कर रहे हो कि मैं इसका आंसर दूंगा. No way. 49th is shape of the meniscus formed by two liquids when capillaries are dipped in them are shown. If one is hemispherical whereas two is flat, Pick correct statement regarding contact angles formed by the liquids in both situations. It is 180 degree in one, so this is hemispherical, right? Here's a different. Okay. I mean, it's 0 in the first guy, और इसमें 90 degree है. So B is the thing. और कुछ दिया नहीं इसमें, so whatever. 50. For fluid which is flowing steadily, the level of the vertical tube is best represented by steady flow fluid, हाँ? Of course. So यहाँ पे velocity ज़्यादा रहेगी, so center से यहाँ तक का जो height है इसमें भी less, hydrostatic pressure कम होता है, right? और similarly यहाँ पे बड़ा रहेगा, which makes sense, क्योंकि उन लोगों ने वही किया है. Yes. कम velocity ज़्यादा pressure. और ये तो इन लोगों ने सेम कर दिया, just not correct. Oh God, ये क्या है? D is just rubbish. B भी कुछ सही नहीं लग रहा है मुझे. Like यहाँ पे ये कैसे हो गया? 0? Okay, I don't know. Right. It should be more. So I guess B is correct. थोड़ा ज़्यादा है इसमें, right? From the central point, datum से थोड़ा ऊपर है. Isn't that correct? Yeah. तो datum क्या बोल रहा हूँ? ये जो thickness है इससे ऊपर, right? So B is the correct one. Done. Okay. Oh नहीं, अभी थोड़ा रुकना है, अपने को चेक करना है first of all. Yeah. आंसर की 50 का A है. I don't know. You know, seriously, I don't think कि वो जो भी करते हैं उनमें से मैक्सिमम चीजें करेक्ट भी होती है. So चेक किसका टाइम बर्बाद कर रहा हूँ. Instead of that, yeah, just skip all that. So that's it. I'll see you in the next video.